Welcome my friends. In this video I'm going to teach you the rules for trig substitution. So whenever you have integrals that have the radical like that, and you have a pattern where a is a constant greater than 0 and u is a function, and then you have this inside the integral, and the integral may have other functions here and here if you have a fraction, but the main thing you have to concentrate is the radical. You have to do a trig substitution in order to get rid of the radical, because you don't want those radicals. So I went ahead and solved each case, and I wanted to explain to you how I got it. I wanted to make sure I did it correctly, so that's why I did it in advance on the board. Okay, so for this thing you need two trig identities. You need sine squared plus cos squared equals 1, and secant squared minus tangent squared equals 1. So what you do is you let u equals a sine theta, then you plug it in for u, then you get 1, and then you pull out, then you get this here, a squared minus a squared sine squared theta, then you pull out an a, you factor out an a, and then you're left with 1 minus sine squared theta. Then using this trigonometric identity, you put a cos squared theta, then you take the radical, you get a cos theta, and then the theta goes between negative pi over 2 and greater than or equal to negative pi over 2 and less than or equal to pi over 2. Now this pattern here is similar to this one. The only difference is that here we have a minus, here we have a plus. In this case you let u equals a tangent theta, then you plug it in for u, you get this. Here you factor out the a, and inside the radical you're left with 1 plus tangent squared theta. Then using this trigonometric identity, inside you put secant squared theta, then you solve it and you take the radical, you get a secant theta, and secant theta runs between greater than negative pi over 2 and less than pi over 2. For the third pattern, the difference between this and this is that you flip the function, and now the constant is at the right side. So for this case you let u equals a secant theta, you plug in a secant theta for u, you get this, then you factor out the a, and inside you get secant squared minus 1. Then you use this trigonometric identity, and you're gonna substitute a radical tangent squared theta. But this case is a little different because u could be greater than a, or you could be less than negative a. So in that case you have two cases. When u is greater than a, you take the radical and you get a tangent theta, and because we're working with tangent theta, when u is greater than a, that means that the theta runs between greater than 0 and less than pi over 2, and when u is less than negative a, then you take the radical and you have to put negative a tangent theta, and then you're gonna be the theta of the tangent is gonna run between greater than pi over 2 and less than pi. So these are you don't have to do this all the time actually, these steps. Actually all you have to do for for doing this integral is when you see this pattern, you remember, if you want, you can put let u equals a sine theta, and then at the end all you have to do is substitute. Instead of this radical, you're going to put a cos theta. Same thing with this one, a secant theta, and this one a tangent theta, and of course it has two cases. We're going to be looking at integrals like this soon, so just keep in tune. Alright, so thank you, my friends. Don't forget to subscribe. You really help me a lot.